alternative form of equation of a circle. In our last lesson, we had established that the equation of a circle centered at the point h, k and radius r is given as x minus h all squared plus y minus k all squared equal to r squared. And we call this equation 1. Now we want to modify equation 1 and arrive at another equation that describes a circle, which we shall call the alternative form of 1. If we expand the left hand side of equation 1, what do we get? We get x squared minus 2xh plus h squared plus, if we expand this other term, we get y squared minus 2yk plus k squared. If we take r squared to the left hand side, we get minus r squared equal to 0. If we rearrange these terms a little further, we get x squared plus y squared plus, I write this term as minus 2h, I put the x out, plus this other term here, minus 2k, I put the y out, plus k squared minus r squared plus h squared equal to 0. If we now say, let capital P be equal to this term minus 2h, and let capital Q be equal to this term minus 2k, and let capital R be equal to these three terms, k squared minus r squared plus h squared. So this equation becomes x squared plus y squared plus, now minus 2h is now p, plus px plus minus 2k is now q, plus qy plus k squared minus r squared plus h squared is now capital R equal to what? 0. I call this equation 2. Equation 2 is the equation referred to as the alternative form of equation what? Of equation 1. Now, if a circle is described using equation 2, the question is it possible to also find out what the radius of the equation is, as well as the center coordinate? And the answer is yes. Now, to get the center and the radius of this equation 3 of the circle that is described by equation 3, we do the following. If we rewrite equation 2 as x squared plus px plus y squared plus qy equal to, I take the r, the constant term, to the right, minus r. What do we observe? We observe that the term x squared plus px is an incomplete word quadratic term, as well as the term y squared plus qy is also an incomplete word quadratic term. So what do we do here? We say we complete what? The squares. Let us try to explain, let us try to understand what we are really seeing here. We are saying that, look up here, if we have the term x minus y all squared, for example, now when you expand this term, what do you get? You get x squared minus 2xy plus what? Plus y squared. So what do we see here? We see that a complete quadratic expression has three terms, or what we call is a trinomial. It has a first term, the second term, and the third term. Okay, so x squared minus 2xy plus y squared is the same thing as x minus y all squared. So if you look at these terms here, x squared plus px, there are just two terms here, which means that there's a third term that is missing. You look at y squared plus qy, there are just two terms also, which tells us that there's also one term that is missing. Now, to get this one term that is missing here and here, we perform what we call completing the square. So we now do what we call, we have to complete the square. Why are we doing that? Because the squares are actually incomplete. Now, so we must complete the square on x and equally complete the square on what? On y. And recall, whatever we do to the left hand side of the equation, we must do also to what? To the right hand side of the equation. To complete the square on x, this is what you do. You say 1 over 2 multiplied by the coefficient of x here is what? Is p. I didn't say of x squared, we said of x is p. So times p gives us what? 1 times p is p over 2. You square it. Now for y, the same thing. 1 over 2 times the coefficient of y here is q times q. And that gives us what? Q over 2, and then you square it. These are the terms you add to both of x and y. So if you do that, this now becomes x squared plus px plus, to now make this x a complete square, we now add p over 2 all squared plus y squared plus qy. To make y a complete square, we now add this term plus q over 2 all squared equal to minus r. Since we have added these two terms to the left hand side, now for equality to be maintained, we must also add them to the right hand side. So p over 2 all squared plus what? Q over 2 all squared. Are we following? This is now a complete square for x, as well as a complete square also for y. Now if you recall what we had explained earlier, we said that x squared minus 2xy plus y squared, a complete square, can be written as what? X minus y all squared. So going by that, we can now write the complete square for x as x plus p over 2 all squared. Because if you expand this term, you get back this term. For that of y, we have y plus q over 2 plus q over 2 all squared equal to, and the right hand side, let's tidy it up. We get this is minus r plus, if you open the bracket, you have p squared over 4 plus, this gives us what? This gives us q squared over 4. So you will tidy up the right hand side. What do we get? So what we have there is, we have x plus p over 2 all squared plus y plus q over 2 all squared equal to, we have p squared over 4 plus q squared over 4 minus r. If you take the LCM on the right hand side, we have 4, and that gives us p squared plus q squared minus 4r. So we have that x plus p over 2 all squared plus y plus q over 2 all squared is equal to what? P squared plus q squared minus 4r all over what? R, all over 4. If we compare this equation, I call it 3, to the standard center radius equation, which is what? X minus what? H squared plus y minus what? K squared equal to r squared. If we compare these two equations, what do we observe? We observe that the center coordinate, so the center coordinate h comma k is what? H, what is h here? H here will be negative p over 2, and what is our k will be negative q over 2. Now if we compare these two here, our r squared will now be p squared plus q squared minus 4r all over 4. So that our r is now what? Our r now becomes the square root of p squared plus q squared minus 4r over 2. So if we are given the equation of a circle in the alternative form, x squared plus y squared plus px plus qy plus r equal to 0, the center of the circle given in this form becomes what? Minus p over 2 comma minus q over 2, and the radius of that circle now becomes r equal to what? The square root of p squared plus q squared minus 4r all over what? 2. In our next lesson, we shall solve problems using this method.